right, so we've got a cylindrical can. There's our cylindrical can, and we want to know what dimensions will use the least amount of material. So when we're talking about material, that should be what?
Surface area. Be the surface area.
Yeah, surface area. So we're talking about surface area of a cylinder. So I'll call that A. So our surface area A should be this base and this base, which would be what?
2 pi r squared.
2 pi r squared. And then plus, we got the lateral surface area, which should be what?
2 pi r h.
2 pi r h. Okay, everybody good with that? Circumference times height for the lateral part. What's the issue with this formula for area?
There's more than one variable.
Yeah, we need one variable. We got multiple variables, right? We got 2 pi r squared plus 2 pi r h. So we got an r and an h. So we need to find a way to relate the r and the h together. So how are we going to go about doing that?
Is there some way we could incorporate the volume that we already know into finding the height?
Our volume is 2,000. And what's the formula for volume of the cylinder? Should be pi
h.
Yeah, pi r squared h. So we should be able to use that to relate the radius and the height to each other. So that should tell us that height is equal to 2,000 over pi r squared. Everybody agree with that?
Yeah.
Yeah.
Yes.
Cool. So now we can take that value for h and we can plug it in up here. So our area is 2 pi r squared plus 2 pi r times 2,000 over pi r squared. And simplifying that out a bit should give us plus 4,000. The pi's will cancel, and r over r squared is over r, or r to the negative 1. So everybody feel all right that for this particular cylinder, its surface area is 2 pi r squared plus 400 r to the negative 1.
You said 400 R or 4,000 R?
4,000. Did I say 400? If I said 400, I clearly didn't see that last zero that I wrote there. 4,000 r to the negative 1. Everyone good there? Yeah. All right. So let's now take our derivative to see when this area, the surface area, is at a minimum. So that'll be 4 pi r, and then that'll be minus 4,000 r to the negative 2, or I'll just write that as minus 4,000 over r squared. And easiest way to solve this probably is to get common denominator of r squared. So I'll just multiply that one by r squared over r squared, and we end up with 4 pi r cubed minus 4,000 all over r squared. Everybody good with that being our derivative?
Yeah.
Okay. When is this undefined? This is undefined if r equals 0, right? But r equals 0 hopefully doesn't make much sense to us because we're not going to have a cylinder that has a radius of 0, are we? Probably not. So all we really care about then is when is this equal to 0? So when does that equal 0? Well, that'd be if 4 pi r cubed equals 4,000. or if r cubed equals 1,000 over pi, or if r equals 10 over the cube root of pi. Everybody good with that? Any questions on getting to that value?
Good.
All right, so what do we need to do with that r value? We need to put it on a sign chart. And I could probably have room here. This is, let's just do it on a new page. So we've got 10 over the cube root of pi, and something less than that would be like 1. If I plug in 1 to this, to our derivative, we're going to end up with 4 pi minus 4,000, which is a negative over a positive. So negative here. And then if we plug in something more than 10 over the cube root of pi, like for example, 10, that should give us, that'll be 4,000 pi minus 4,000, which is positive, over a positive, so it gives us a positive. So we end up with a minimum when r equals 10 over the cube root of pi centimeters. And if we want the height, we had a formula for the height. Height was 2,000 over pi times our radius squared. And so if we simplify that, 2,000 over 100 is 20. And then pi over pi to the 2/3 is pi to the 1/3, or cube root of pi. So we've got radius of 10 over the cube root of pi centimeters and a height of 20 over the cube root of pi centimeters. Any questions on that? Everybody good with that or no? All right, everyone's good?
Yeah.
All right, let's see what we can do here with this one. We want to find the dimensions of a right circular cylinder of maximum volume that we're inscribing into a sphere of radius 10. So here is my sphere. And in that sphere, we're going to inscribe a cylinder, and my picture is not perfect, but there's the cylinder is not going outside of that sphere. Those are tangent. Every point along this base of my cylinder is touching an outer portion of that sphere at some point. Same with this other base. And then it drops straight through the middle of it. So it's kind of like we, drilled a hole through it or something similar to that. Good or no? With the picture?
Good.
Okay. So all we know in here is that the sphere itself has a radius of 10. Other than that, we don't really know anything. So any thoughts on how we can find the maximum volume of this cylinder? Probably we'll start with the volume formula, which is pi r squared h, right? And we'll note that there's a problem with volume being pi r squared h. What's that problem?
2 variables.
Yeah, 2 variables again. So we got to find a way to relate r and h to each other. And so how are we going to do that? Any thoughts on that? What is h? H is this, right? And then we've got a little r here for our cylinder. And we've got a 10 for the radius of the sphere. Anybody see a way I can relate those 3 things together at all?
Could you connect like the center of the sphere to like one of the like corners of the cylinder to find the radius.
Like that.
Yeah, and then maybe like
That should also be 10.
use some trig stuff.
Yeah, so if I just drop this straight down, what is this length of this right triangle's leg?
1/2 h.
It should be half of h, right? H over 2. So using the Pythagorean theorem, we should be able to say that h over 2 squared plus r squared equals 100. And we can either replace the r's or the h's. I've already got an r squared here, and I've already got an r squared here. So it might make sense to just solve for r squared and then substitute that. So r squared would be 100 minus h squared over 4. So we could substitute that in. Volume is pi times h times 100 minus h squared over 4. Or if we distribute that through, pi equals 100 pi h minus pi h cubed over 4. Good or no?
Good.
All right, what should v prime be then? V prime ought to be derivative of 100 pi h should be just 100 pi, right? Derivative of pi h cubed over 4 ought to be minus 3 pi h squared over 4. And we want to know, when does that equal 0, right? So that'd be if 100 pi equals 3 pi h squared over 4. And simplifying that down, what do you get for h? H should be, that's 400 pi, divided by the pi is just 400. H squared is 400 over 3, so h is 20 over root 3. Good or no?
Good.
All right, if we plug in something less than that, like 1 into our derivative, we'd get 100 pi minus 3/4 pi, definitely positive, so increasing. And something more than 20 over root 3, like let's say 19. 19 squared is 361, divided by 4 ought to be about 90-ish, times 3 is 270, so we got 100 pi minus about 270 pi. That'd definitely be negative. So we have a max when the height is 20 over root 3. And we'll say, what were those, centimeters? And I know it asks for the max volume, but all you'd have to do is just plug that into your volume formula to get your volume of that cylinder. I'm not going to spend the time doing the arithmetic on that. But does that conceptually make sense to find when that's at a maximum?
Yes.
Yeah, that makes sense.
I will note that oftentimes, especially in these like sphere or cylinder or problems similar to these, we're going to end up with a formula that involves an r and an h, and we'll have to find some way to relate r to h. Sometimes it might be Pythagorean theorem. In this case, we had to use both surface area and volume. It just kind of depends on the context of the problem. So let's take a look at this one. Again, this is another cylinder. And this cylinder is going to be opened at the top, and we're talking about costs for making the cylinder. We want to know a minimum cost. So if we want a minimum cost, we need to write a cost equation. And what is the cost going to be? It's going to be, for a cylinder, right? It says that the base of it should be what? 15 cents per square inch. So 15 times the number of square inches in the base. How many square inches are there in the base? Square inches is an area unit, right? So what's the area of the base? The base is a
Pi r squared.
circle. All right, pi r squared. Great. And then what about the lateral surface area, which is 5 cents per square inch? $0.05 times the lateral surface area. So what's the surface area of the sides? That should be
2 pi r h.
2 pi r h. And the problem that we have here is r and h once again. So we're going to use the other information given to us that the volume has to be, it's pi r squared h has to be 24 pi, which tells us that h is equal to what? 24 over r squared if the pi's cancel out. And we should be able then to say our cost is 15 pi r squared plus 10 pi r times 24 over r squared. So that'll be 240 pi r over r squared would be r to the negative 1. Everybody good with that cost equation?
Yeah.
All right, so C prime should be 30 pi r minus 240 pi r to the negative 2. And if we want to get a common denominator, that'll make life a bit easier. 30 pi r cubed minus 240 pi over r squared. And that'd be undefined if r is 0, which again makes no sense for a cylinder. Or when would that equal 0? If 30 pi r cubed minus 240 pi equals 0. Or add the 240 pi and divide by 30 pi, r cubed would be 8, or r would be 2. And what is that? 2 inches, I think, right? So we need to make our sign chart. Something less than 2 would be 1. That's going to give us a 30 pi minus a 240 pi over a positive, which is negative. Something more than 2, like 3, will give us a positive in the numerator and a positive in the denominator. And so we have a minimum cost when r is 2. And if r is 2, h is 24 over 2 squared, or h is 6 inches. Good or no?
Good.
Anybody have any issues, any questions on any of these problems so far? We're going to do one more, and then we'll be done with optimization.
What happens to the r squared in the denominator at 30 pi r cubed minus 240 pi divided by that r squared?
Yeah, no, I mean, nothing happens to it. We have to look at when the derivative is, this is our derivative, right? We have to look at when it's undefined.
Okay. You're setting the numerator to 0. Okay.
Yeah, and we looked at the denominator being 0. We said that'd be when r is 0, but r equals 0 doesn't make sense because then we don't have a cylinder.
Okay. Yeah. Thank you.
Yeah. All right. We are going to have a rectangle that we're going to inscribe under one arch of the sine curve. So there's my sine curve. It's not perfect, but it's okay. And we're going to inscribe a rectangle under. So when we say we're inscribing something under a curve, when we say something's under a curve, it means that it's going to be flush with the x-axis. So we're going to have a rectangle. Pretend that I did. Let's draw a better rectangle. Pretend that that's a great looking rectangle. It's got to be laying across the x-axis because it's underneath the sine curve. So that's what that means, between the curve and the x-axis. And then it's got vertices on the curve. What else could we label on here besides like that this is the x-axis and this is the y-axis and that this is y equals sine x? Could I label this value?
That would be pi, right?
That'd be pi, yep. And additionally, what could we say about this sine curve? We know that sine curves are symmetric, right? Like this arch of the curve is the same from here to pi over 2, right, at pi over 2. This part is the same as this part, just a mirror image of it. So we know that this distance here should be equivalent to this distance here. And what is the distance from here to here? Well, if I measure from the origin to the right on the x-axis, we call that a what kind of value? It's an x value, isn't it? So how far over? I've gone over a distance of x. True? Do you guys agree that that's x units over from the origin to some point?
Yeah.
Yeah.
And if this is symmetric, what's this distance between pi and the end of my rectangle?
Also
X.
Should also be x. And so what is the length of this rectangle?
Pi minus 2x.
Pi minus 2x. All right, so our area ought to be pi minus 2x, and what should our height be? We go up.
1.
Sorry, say that again.
1 minus y.
Okay, not quite. This is 1, right? Right there is the max that it goes to. But where do we measure y from? Y is measured from the origin going up, right? So wouldn't this distance here just be y?
Yeah.
Right, so 1 minus y is actually this piece in between the rectangle and that value of 1. And what does y equal?
Sine of x.
Yeah, so our height should just be sine of x. So our area of this rectangle should be pi minus 2x times the sine of x. Everybody feel okay about that or no?
Yeah, that's good.
All right, so what's a prime? Product rule, right? Pi minus 2x times the derivative of sine x, which is cosine x, plus sine x times the derivative of pi minus 2x, which is negative 2x. And that equation is one that I don't think you're going to be able to solve without a graphing calculator. I'm just going to use Desmos just to save us a bit of time. Once I get my TI-84 little emulator calculator that's on my laptop working again, which it's still not working, then I'll show you how to do all that stuff on the graphing calculator. But let's graph that and see when it equals 0. So we had what? Pi minus 2x times cosine x plus sine x times negative 2. Does that sound right?
Yeah, that's right.
All right, cool. So we got lots of places where this equals 0, right? Negative 7.959. Well, that one doesn't make any sense because we're not going to have an x value that's negative, are we? Right, I mean, x right here, I'm going from here to here. That's not going to be a negative value, is it?
No.
In fact, what does x need to be between? X has to be greater than 0, but it has to be less than,
Pi over
Pi
2.
divided by 2.
yeah, pi over 2, because I can't go more than halfway, right? Because then I've got, how am I going to go? I mean, it's not going to make any sense to do that. So x has got to be between 0 and pi over 2. So if we go back and look at this again, well, none of these negative ones are. This one is, that's 0.71, right? What about this one? Is that between 0 and pi over 2?
No.
No, pi over 2 is right here, right? This is pi over 2 where this minimum is on the derivative. So the only value that we get is x equals 0.71. So we will say a prime equals 0 if x is about 0.71. And the sign chart for this should be really easy because all we care about is whether the derivative is positive or negative. And here's a graph of the derivative right here. To the left of 0.71, the derivative is positive. And to the right of 0.71, the derivative is negative. So we're positive, then we're negative, increasing to decreasing. We have a max area if x is about 0.71. And I know it asks for the dimensions. I mean, you could go back in and find the sine of 0.71. That'd be your y value. Your x value, or your length of your rectangle, would be pi minus 2 times 0.71 for your width. And the area would just be the value you get when you multiply all those over n. So if we were, I'm not going to do all that because that's just arithmetic, but plug into, this is our length, this is our width, plug into L and W and A, if we wanted to answer all the questions in there, but that's just arithmetic, so we won't do that. Any questions on the process and the calculus behind all that?